Hi, I'm Mr. V, and today we're talking about Illustrative Mathematics, Unit 2 on Congruence, Lesson 8, the Perpendicular Bisector Theorem. And the first thing I would like to do is to look at the objectives for today. So I'm going to go fast forward real quickly to the very end. And at the end, the lesson summary says the perpendicular bisector of a line is exactly those points that are the same distance from two endpoints of a segment. This idea can be broken down into two statements. The first is that if a point is on the perpendicular bisector of a segment, it must be the same distance from both endpoints of that segment. If a point, and the second part of this is the converse of that. So if a point is the same distance from two endpoints of a segment, then it must be on the perpendicular bisector. So the one is the converse of it. If it's an if this, then that. The converse is when you switch those arguments and have if that, then this. So if it's on the perpendicular bisector, it must be the same distance from both endpoints. And the converse is if it's the same distance from both endpoints, then it's on the perpendicular bisector. Now, converses don't always have to be true, but in this case, it happens to be true. So that's good. So we're going to look forward to this lesson here, the perpendicular bisector theorem. By the end of the lesson, you should be able to say, I can critique an explanation of the perpendicular bisector. And the second is, I can explain why the perpendicular bisector theorem is true. Perpendicular bisector theorem says, if a point is on the perpendicular bisector of a segment, then it is equal distance from the endpoints. And we're going to start here in just a moment looking at the converse of that, which is if it's the same distance from the endpoints, then it must be on the perpendicular bisector. So first we have which one of these do not belong. There's 4 of these. You should check them out. And I'm going to show you some results that some students said. Some students said, let me move my picture here. Some students said A doesn't belong with the others because it's the only one with an L in it that's horizontal. It's also the only one where the lines aren't necessarily perpendicular. Some reasons B doesn't belong. It's the only one with a 90-degree angle that's marked as a 90-degree. And it's only one with one angle marked. C doesn't belong. Some students said it doesn't belong because it's the only one with 2 congruent angles marked. And it's the only one with 2 angles that are marked. And you'll notice that this is a straight angle that we call that a linear pair. That it means it adds up to 180. And if both of these angles are congruent and it's 180, means each one of these is 90. And that's going to play a factor in later on in this discussion for today. Finally, why doesn't C belong? C doesn't belong because it's the only one with symbols describing the diagram. And it's the only one with lines K and L. We draw figures, we mark the drawings, we write symbols, and this is the one with the symbols that are written. Okay? The second activity was called Lots of Lines. And you should name one thing that you notice and one thing that you wonder. And after you type your answer, you can check here. Let's see. Some things that some students noticed. They said it's a triangle. Yeah, it's a triangle. Segments PA and PB are congruent. That means it's isosceles triangle too. Let's see. There's a dotted line. Yeah, duh. And angle A is congruent to angle B. Well, why? Because of the isosceles triangle theorem, which we proved just a couple of days ago. So what are some things that you might have wondered? These are some things that some students wondered. You should write down your own wonderings first, but you can read. I'm going through these now to show you some things that students did. And I'm doing it relatively fast, so I hope you've watched the lesson or tried to do the lesson before watching the video. Is the dotted line a line of symmetry? Is the dotted line perpendicular to segment AB at C? And is C the midpoint of segment AB? All interesting questions which are going to come up in today's lesson. So this is the meat of this particular activity. You have these 3 people, these 3 kids, Diego, Jada, and Noah, were given the following task. Prove that if a point C is the same distance from A and B, that means if it makes an isosceles triangle, then C must be on the perpendicular bisector. At first, they were really stuck, and Noah said, how do you prove that a point is on the line? And the teacher gave them another hint. She says, another way to think about it is to draw a line, an auxiliary line segment that you know that C is on, and then prove that the line has to be the perpendicular bisector. So instead of proving that the point has to be on the line, why don't you prove that this point, if you know something about it, then you can show that it's going to be a perpendicular bisector. And they each thought about it, and they each drew a line. And then they thought about their pictures and what they chose to be special about their line, and their rough drafts are shown on the following slides. Now, every one of their drafts has something that's good, something that they really understand, and something that's not very good. And you should ponder these first. So I'm giving you a spoiler alert. I'm going to go through these and talk to you about what they are, but just watching me do it doesn't give you the mental thinking part of this that you need. You really ought to be thinking about it yourself. In fact, I'm going to let you try to do it. Before you do this, you should try doing this yourself. Try doing what they were supposed to do yourself. So you could construct a triangle, and we could call this A, B, and C. And we want this to be, these two sides to be the same. So I can actually label this. I could label this A and this one B. And I could label this last one C. So CA and CB are congruent, which is what they had to deal with. I could also check the sides, and I can verify that they're congruent. If I click on the label, it'll tell me how long each of these is. They're supposed to be the same. Well, they're not quite the same. Let's see, I can make them the same. I can move this one just a little bit longer. Maybe I can make it, I don't know if I can make it exactly 7. I'll try 7. If I can make this one 7 too, that'd be good. There. Now I know that these two are the same because I've constructed it that way. This is what she started off with. Construct a triangle to represent ABC, CA is equal to CB. And then it says to draw a line from C to the opposite side. And I can define this line. I know it's going to go through C, and I know it's going to go through the opposite side. But how do I define this line? How is this going to help me prove that this line has to be the perpendicular bisector? That's what you need to tell me. What do you know about this line? When you drew this line, what did you make special about it? What did you, because you can put an auxiliary line pretty much anywhere you want. Well, let's read what Diego, Jada, and Noah did. Diego's approach was, I drew a line through C that was perpendicular to AB and went through the midpoint of AB. That line must be the perpendicular bisector of AB, and C is on it. So it proves that C is on the perpendicular bisector. And when you discuss this, what do you think that Diego notices and it says is correct? I think that he knows that it's got to be a perpendicular bisector. To be a perpendicular bisector, it has to be perpendicular and has to cut this in 2 points. But I think he's got some serious issues when he says that he creates this line and it's going to be through C and be perpendicular and be a midpoint. You know, you can usually choose one thing you want the auxiliary line to be, but you can't just make it up. And here's an example why. So here I have a line. I'm going to have a triangle and have this green line. Notice it's perpendicular. No matter where I put it, it's going to be perpendicular. And I have this orange line, which is going to be an angle bisector. It cuts these angles in half. And I have this red line, which cuts the segments into 2 segments. And they don't coincide. They're not all the same. Well, they do coincide if I draw it like this. But I don't know if they coincide or not, just based on what we've got here. And that's what Diego said. He said, well, it's perpendicular and it's the segment bisector, the perpendicular bisector. So I would suggest to him that he choose one or the other and then work from there. Now let's go to the next one. This is Jada's approach. And I'm going to mark her drawing like I would want you to do as you go through this. It says here, I thought C would go through the midpoint of AB. And so she marks that. She drew it. She marked the midpoint here. Mark segment AB and BD are congruent. She said we were told triangle ABC is isosceles. That was that AC is congruent to BD. So she can mark these two as congruent. There we go. Now I've got a side with the one triangle, a side with another, a side and a side. She said angles A and B are congruent. Why? Well, because the isosceles triangle theorem, which we proved 2 days ago, says that the base angles of an isosceles triangle are congruent. Okay, wait a minute. I've got side angle side, side angle side. I know that I've got a side angle side triangle congruence theorem that says that the two triangles must be congruent. She says so too. That made the two triangles congruent by the side angle side triangle congruence theorem. And I use shorthand to write it like this. You can write the whole thing out if you want. I'm just going to write it like this. Then she says, I know that ADC, angle ADC, this angle, is congruent to angle BDC, this angle. Because the corresponding parts of congruent triangles are congruent. So since the triangles are congruent by the shortcut, you can say that these two angles, which are parts that I didn't specify before, have to be congruent. She says, but I still don't know if the DC is the perpendicular bisector. What could you tell her? First of all, I would say bravo, because she's got so much of this right. She noticed the isosceles, the base angles. She used what was given. She wrote that these two were congruent. You should put this line anywhere. She could have said it was perpendicular. She could have said it was an angle bisector. She chose to say it was a segment bisector. And then she gets to CP/CTC, which is great. Well, these two angles are a linear pair. And that would be my hint to her. I wanted to give her more. I'd say they add to 180 and they're both the same. So what angle adds to itself to be a 90-degree angle? Since it's 90 degrees, these are perpendicular. Since it cuts this in half, it's a bisector. It's a perpendicular bisector. C has to be on the perpendicular bisector. Let's go to the next one. See what Noah's approach was. In the isosceles triangle theorem, Mike and Kieran, this was like 2 days ago when we did the isosceles triangle theorem, they drew an angle bisector. So that's what he does. He starts off, says, I'm going to draw this line, this auxiliary line, call this D where it meets, and I'm going to make sure that these two angles are congruent. And after making sure the angles are congruent, he says, it was given that AC is equal to BC. The isosceles triangle theorem tells me that the base angles of an isosceles triangle are congruent. Now look at what he's got here, folks. He's got angle, side, angle. And we know there's a theorem that we can use. I don't think he knows that. He says, so the triangles are congruent. Why? You need to tell him to put some reasons down. It's because the angle side angle triangle congruence theorem. This says that two triangles with an angle, two angles that are congruent, and the side that's in between, the included side, proves that the two triangles are congruent. And then he goes on and does more without giving me any reasons. He says, since the triangles are congruent, AD is equal to BD. Well, AD is equal to BD. AD is equal to BD. This is congruent to this. And that's true, but he doesn't give me a reason for it. And you need to tell him. You need to put some reasons down. What's the reason? After I use the shortcut, ASA, angle side angle, to prove the triangles are congruent, then I can show that all of the remaining parts that I didn't use to prove they are congruent, all the remaining parts, the corresponding parts of the congruent triangles are congruent. So yeah, these are congruent because it's the corresponding angles are congruent. He also says that angle ADC, and these two angles are congruent. This one here is congruent with this one here. And that's true too because of CP/CTC. But he's stuck. And he's stuck on the same thing that Mai was stuck on, and that is that, hey, these two angles are the same. Remember from the bell work when we did this on Notice and Wonder? If they're the same and they add to 180 because they're a linear pair, they have to be 90. Since they're 90, since they bisect this segment, these are a perpendicular bisector. C has to be on the perpendicular bisector. This proves the converse of the perpendicular bisector theorem, which is that if a point is equidistant from two endpoints, then it must be on the perpendicular bisector. So let's try to prove the perpendicular bisector theorem. Here it says if a point is on the perpendicular bisector, then prove that it is the same distance from A as it is to B. And you can discuss your graphs, and you can try this, and I want you to try it. And then I'm going to give you a hint here. Did you think to connect the points, make a big triangle? How does this help? What shortcuts have you learned? What triangle congruence theorems have you learned that would help you with this? Because if you could show that the two triangles are congruent, then maybe you could say that the parts are congruent, and you could do like the others did and say that. So let's try this. Here's the spoiler alert. This is the actual solution. It says PM is on the perpendicular PM is the perpendicular bisector because it was given. Now I can move PM anywhere I want to on this. I'm going to construct the actual triangle. I'll construct a triangle here. And I actually have two triangles that are split by this piece in the middle. This piece in the middle cuts this into two equal parts because we drew it that way. No, because it said it was a perpendicular bisector. This is 90 degrees. This also means that this other angle, PMA, has to be 90. If you measure it, you can see 90, 90, they add to 180, of course. And we know that PM is congruent to itself because of the reflexive property. So this triangle on the left, which we called AMP is congruent to BMP by the side angle side triangle congruence theorem. Since these two triangles are congruent, using these three pieces of the 6 pieces, I can say that the remaining pieces must be congruent, corresponding parts. Corresponding parts of congruent triangles are congruent, so AP is congruent to AB. That means that the distance has to be the same from A as it is from B, because they're congruent. This is the perpendicular bisector theorem. If point P is on the perpendicular bisector of segment AC, then point P is equidistant from the endpoints of that segment, which means that the triangle formed by that point on the segment is an isosceles triangle. Write this and put this into your reference document. And here we have the cool down. Based on what we see, what do you notice about this image? First of all, I noticed that it has, what must be true is PA must be equal to PB. This must be isosceles. We know that P must be on the perpendicular bisector of the triangle. If PC is a perpendicular bisector, that means that it's perpendicular. It cuts this into two congruent segments, and it cuts this angle into two congruent parts. So it depends on where I put C. If I put C as the bisector of this segment, we know it's also got to be perpendicular and it has to bisect this angle. If I put it as an angle bisector by the side angle side triangle congruent theorem, the two triangles are congruent. So this is perpendicular and it cuts AB into two equal parts. If I draw this as perpendicular, then I have this is perpendicular and this is congruent to itself. And we haven't studied the side angle triangle congruence theorem yet, but we will, and then you'll be able to see it. Now, on this page, you get to tell me what you think, and here is the lesson summary. Please read the lesson summary, and good luck and success.